Welcome back to Make It Mental right here, everybody. Today you're looking at the continuation of my steering slop fix, and as you can see by my lower bolt here, I got that one completed, and I actually have this one completed too. It's got a stainless steel sleeve inserted into there. I had a change of plans. I was going to run the stainless steel sleeve all the way up to the top right there, but there's a reason why I changed it. See this, where is it? Where's the other one? Well, this brass that you see right in here, it's covered in grease. This is actually a dielectric grease. That brass actually rides against this surface right here, which I had no problem with. And then I was just going to drill out this hole to accept the stainless steel sleeve. So I ended up cutting a stainless steel sleeve basically flush with the brass. So now this is fixed. The stainless steel sleeve can rotate inside the brass and around this aluminum hex piece right here. So we got basically a bearing within a bearing to help reduce wear and tear, right? Well, if one binds up, the other one can take over, right? And so kind of like having redundancy built in, which is a nice feature. So I decided against drilling out the plastic. So now I'm working on the steering mechanism where this link here would connect, right? Well, actually it'd be right there. And this little screw right here is where the secondary part of the slop is, and I'm not sure I can fix this one. Focus. I really thought the blue would work out better. There we go. Congratulations, you win a donut. You can see that, how it's hanging right there. That is just a lot of slop. Sorry for my dirty fingernails, but yes, I am an automotive mechanic, and sometimes I work on the nastiest, dirtiest fucking cars and trucks that ever roamed the face of the planet, right? So there is a lot of slop right there. And Red Cat, you know, they designed it to actually have a metal sleeve in there. I don't know how well that will show up on camera, but there is a metal sleeve in there. And let's turn it around. Maybe it'll be seen better here. Yep, there we go. There's a better picture. All right, so there's a metal sleeve. Turn it off to the side a little bit. So that metal sleeve is worn out, so I'm not sure I have anything in that size. I'm gonna have to do some hunting and see if I got something in that size. If not, it is what it is, and I'll still have some steering slop, but not nearly as bad as I used to have with these jokers here at the hexes. Right? And I don't want to pull them out of there because I got them lubricated with some dielectric grease. I like that kind of grease because it does a good job of staying where you put it. Right, just lubricate the inside, lubricate the shaft, which is this piece right here in my particular case, right, and then put some around on my thumbnail around there, and then squeeze it up in there because that's a pivot point as well. Lubricate all of your pivot points, get everything cleaned up. The shiny shit you see on there is super glue. I actually did have to super glue the brass to the plastic several times because it kept wanting to come out every time I drilled it. Then once I finished drilling it, I needed a different drill bit to actually drill it more accurately. So I used a piece of the leftover stainless steel tube, which is still quite a bit of it, and I simply put some notches in it with my rotary tool. And this acts like a core sample drill bit. You know, it's not perfect, you know, because I just eyeballed it and put some notches in there, but that gave me an exact cut. And if you're going to do something like this and then you're drilling out your bearings or your brass, for example right there, put your drill, check this into your drill, go as slow as possible. Slow. You want to be very, very slow, right? So that's how it works. Go very slow, maybe even put a little bit of grease or some sort of lubricant on there as you're cutting, and light pressure, very light pressure. Let this thing do the cutting, and in theory, as long as all these things are straight and not bent out of whack, I should end up with an exact hole, which I did, that I needed for this sleeve, which is right there, right? So that's how that works. Just like that. A sleeve within a sleeve, a bearing within a bearing. And that should reduce a lot of the steering slop that I had. And that may not work for your particular vehicle, but if you watched a few videos I made on this subject, it should give you a good idea on how to tackle it on your particular application, because what you're looking at here may not work for you. So you just have to be inspired, get creative, and adopt the necessary means to make it happen.